Okay, guys, here's side 2 of the honors unit, topic 22. The first part is topic 22b, and remember, 22b is all about proving whether a quadrilateral is a parallelogram. And there's 6 ways to do that, and we've talked about them. It says label the following figures such as each represents a different method for proving it is a parallelogram. So how can I mark these diagrams to guarantee that I'm going to have a parallelogram? So I'm actually going to do all 6 for you. So I'm just going to kind of go in order the way I memorize them. Sides are parallel, then that is enough information to prove that my quadrilateral is a parallelogram. That's really just the definition of what a parallelogram is. Okay? My second way is if I know that both pairs, right, both sets of opposite sides are congruent, that is also enough information to prove that my quadrilateral is a parallelogram. Okay, number 10. If I know that I have 2 sets of opposite congruent angles, that is enough information to prove that my quadrilateral is a parallelogram. If I know that one angle, let's say this thing here is 110 degrees, is supplementary to its 2 consecutive angles, I also know that's enough information. Notice the difference between 10 and 11. And number 10, I didn't give you any values. I just know that these are the same and these are the same. And number 11, I'm saying, okay, I know that this plus this adds up to 180. I know that this plus this adds up to 180. You don't necessarily have to have values, but I need to know that these are supplementary and these are supplementary. And as a default, that means that you're going to essentially have one set of opposite congruent angles, and then each of them are supplementary to this one. So that's enough information. I would not want you to mark any more information than that in your picture if you use this one. For our last 2, I know I don't have them room for them on here. Let's see if I can remember them off the top of my head really fast. If I were to do number 5, the next one I could do is I could show that my diagonals were bisected. So if a quadrilateral's diagonals are bisected, that would be enough information to prove that a quadrilateral is a parallelogram. And then my last option is to show that one's congruent and parallel. So that is also enough information. So on the test, be prepared to be able to draw them, be prepared to be able to explain them in words, or be able to like see a picture and know if it qualifies as one of our 6 reasons. Okay, and that's all 22b. We did it on that like review for proofs page we did on quadrilaterals, and it's also on one of the notes from like the first days of the unit. Okay, let's move on to number 12. It says solve for the following angles in the given parallelogram. Well, if we know this is a parallelogram, that means that these sides are parallel, these pairs of sides. We know that these sides are congruent, these sides are congruent. We know that opposite angles are congruent, so this has to be 110. Let's see if we can figure anything else out. I know, for instance, that this side is parallel to this side down there. Remember, if I can make that Z, my alternate interior angles will be congruent as long as I know that my sides are parallel. They are. So this and this are all interior angles. Those will both be 30. Okay, well, we also know that this whole angle has to be supplementary to this whole angle. This is 110, so this whole thing has to be 70. So if this is 30, this will be 40. That means this has to be 40 as well. So let's see if we can fill in the problem now. The measuring angle QRP, so Q to R to P, so this thing right here is 30 degrees. The measure of angle QPR, so Q to P to R, that's going to be 40 degrees. The measure of angle S, this whole thing is 110. PRS, so PRS, that's going to be 40 degrees. Okay, notice we had to tell you that this shape was a parallelogram. Let's look at number 13. Find the values of all the missing angles in the following. Notice isosceles trapezoid. Well, if it's an isosceles trapezoid, we know, first of all, that our base angles will be congruent. Well, let's start by labeling this picture. These are my bases because they are the parallel sides. These are my legs that in this case are congruent because it's an isosceles trapezoid. We know that base angles, so angles on the same base will be congruent. So these two have to be the same. And these two have to be the same. That means angle 1 has to be 109 degrees. We also know that leg angles, and this is for all trapezoids, not just isosceles trapezoids, have to be supplementary because if these sides are parallel, right, then these are going to be same side interior angles, and if they're parallel, same side interior angles have to add up to 180. Remember when we did our dots and our stars, we had like dot, star, star, dot, right? These would have been, this would have been like a dot, this would have been a star. They have to add up to 180. So if I subtract 109 from 180, this is going to be 71 degrees. And now we know that these two also have to be congruent because they're base angles. They're on the same base. So this will be 71 degrees as well. Okay, on to number 14. It says, given this is a rectangle, that's important. So think about what we know about rectangles. If the measure of angle 1 is 50 degrees, so this is 50 degrees, find the measures of the missing angles. Okay, well, let's think about what we know. I know, for instance, that these two sides are parallel. So I'm going to get alternate interior angles, right? So that means that this has to be 50 degrees. So angle 3 is 50 degrees. Okay, I also know that because it's a rectangle, these two have to add up to 90. So this has to be 40 degrees, right? All the angles in a rectangle are right angles. Okay, so this is 40 degrees. That means this also has to be 40 degrees. Okay, let's see if I can figure out anything else. Well, I also know that because this is a rectangle, that this diagonal is the same as this whole diagonal, which also means that their halves are going to be the same. In a parallelogram, we know that these two diagonals are exactly the same, these two halves, that gets bisected. Because the whole diagonal length is the same, I also know that these are going to be the same. That means this is an isosceles triangle. So if this is 50 degrees, this is also going to be 50 degrees. So angle 5 is going to be 50 degrees. These have to add up to 90, so angle 6 will be 40 degrees. And now I can just fill in the rest. So here's my other isosceles triangle. So if that's going to be, we didn't need to solve for 9. This is going to be 40. Well, we know that any three angles in a triangle have to add up to 180. So these three have to add up to 180. I've already used up 50 and 50. That's 100. So that means I have 80 left for angle 7. I know these two have to add up to 180 because they form a linear pair. So angle 8 has to be 100 degrees. Okay, on to number 15. Solve for x and y. Well, let's look at the picture first and determine. We know this has to be a kite because a kite by definition has two pairs of consecutive congruent sides. So I know that this has to be a kite. Okay. Let's think about what we know about a kite. We know that a kite's diagonals are perpendicular. I also know that I can fold a kite in half. So for instance, I know that if this is y, this will be y. If this is x, this will be x. So let's take a look. Wait a minute. If this is 90 degrees, I now have a triangle right here. These three have to add up to 180. So I can say that x plus 39 plus 90 have to add up to 180. So I'm going to subtract those on both. So 39 is going to go over, 90 is going to go over. And I'm left with 51 for x. Well, now let's look down here. This is going to be 54 degrees. I have 90 degree and y. I also know that 54 plus 90 plus y is going to equal 180. So if I subtract these two values over to this side, I'm going to be left with y equals 36. Okay, so remember this is a kite, which means that its diagonals intersect, are perpendicular when they intersect. Or I should really just say the diagonals are perpendicular. Okay, number 16, solve for x and y in the following rhombus. Well, wait a minute. What do we know about rhombi or rhombuses? We know that all of their sides are congruent. That means this side is congruent to this side, which is congruent to this side, which is also congruent to this side. Well, I'm going to look for the two variables, or two sides that have the same variable. Notice these sides both have x. So I'm going to say that 4x minus 2 is equal to 3x plus 3. I'm going to subtract 3x over. I am going to add 2 to this side, and I get that x equals 5. Well, if x equals 5, that means this side, 3 times 5 is 15 plus 3 is 18. 5 times 4 is 20. 20 minus 2 is 18. That lets me know that my value of x was correct. I got the same length for both of these sides. Well, that means this thing up here also has to have a value of 18. So if 2y equals 18, I divide by 2, and I get that y equals 9. Okay, over here, this is a trapezoid. This problem is going to be a trapezoid mid-segment theorem problem, and we know that if I add the two bases and divide by 2, I get the length of the mid-segment. The first base is x plus 3. The second base is 4x plus 7. and the mid-segment was 15. So if I combine my like terms, I get x and 4x is 5x, 3 and 7 is 10, and then I have 15 on this side. I personally like to multiply both sides by 2 to get the 2 on this side, but if you wanted to divide this by 2 and this by 2, you could. So I'm going to get 5x plus 10 is equal to 30. I'm going to subtract 10 on both sides, and I get 5x equals 20. And if I divide both sides by 5, I get that x equals 4. Well, let's take a look to make sure that makes sense. Up here, I get a value of 7. Down here, I get a value of, so 16 plus 7 is 23. 7 plus 23 is 30. 30 divided by 2 is 15. So that looks good to me. Okay, guys, I'm going to pause this video, and I will start another one on page 3 in a moment.